Okay, we're going to graph. We're not going to create a table of values for y equals log 2x. We're just going to graph it. And we're going to graph them beside each other instead of on the same graph. Just, it's easier to see. And that's what we've done in our transformations unit. So the same transformations that we have done for all of our graphs, we can now do for log graphs as well. So if we graph log base 2 of x, same as our last question, you know that you're going to have the point 1, 0. And with the base 2, you'll have 2, 1. Noticed I went through the points better this time, concentrated a little bit more. You didn't get a ticket? Okay, whew. And there's x equals 0. So there is our graph of y equals log 2 of x. And now, over here, we're going to graph what happens when we want to graph log base 2 of 2x minus 1. Nice. That's going to come up very loud online. Yeah, that's good. The plan is these videos are just for this class, and I'll make new videos next year with the next class. I don't want the stupid video thing to take away from the jokes that we make in class. Except if we make inappropriate ones, then I have to edit that out, I guess. Okay, so what do we have here? What does that 2 do? What does this 1 do? You have to realize, and this is what makes, you have to realize that this 2 is part of our regular graph. And so this 2 here, which is part of our parent graph, does not affect the transformations. So even though you've added another, there's a number there, you have to know that doesn't affect what happens to the graph. So just this first 2, which is going to be a horizontal compression, you're going to multiply x by a half. And then the minus 1, is that inside the log or is that minus 1 outside? It's outside, so it's going to move it down 1. So let's look at our 2 points. We have 1, 0, and we have 2, 1. You do all your stretches and reflections first. We just have 1, which is x by a half. And then we move it down 1. And we get our new points. Is anything going to happen to the asymptote, which was at x equals 0? No, because the only way your asymptote at x equals 0 gets changed is if your graph is shifted left or right. And it's just been shifted down, so it's going to stay at x equals 0. So when I'm graphing after transformations, I always start with my asymptote, label it x equals 0. We now have the point 1, 0, and a half, negative 1. Whenever you're making a graph, you always have to have something on there that determines what your scale is for your x-axis and what your scale is for your y-axis. Having these 2 points labeled, I have said that this ticking mark is minus 1 for my y. So any other ticking marks that I make will be increments of 1. I have labeled this point as 1, so if I make more marks along there, it'll be implied that they're 1. It wouldn't be enough just to label this point, because 1, 0 doesn't tell me anything about my y. But as soon as I label a second point, I have a clearly labeled graph, and I can sketch the rest of it. So we've got the same asymptote for part C. We've got an a y-intercept labeled there. Sorry, an x-intercept labeled at 1, 0. There is no y-intercepts. For this second graph, the domain is still bigger than 0, and the range is still everything. And the questions you can do are 8, 9, 10, and 11. And I'm going to give you 2 additional questions to practice on your own for graphing together before we get to those ones in the homework. I would like you to graph y equals 4 log base 3 of x plus 1 minus 5, and y equals 2 natural log of 1/2 x plus 2 minus 3. So I'll put up the answers for those in a couple minutes. All right, I will put up the answers here. Each time you can quickly draw your parent graph. The parent graph here would be log base 3 of x, so you'd have an asymptote at x equals 0, 1, 0, and because it's base 3, you'd have 3, 1. So there's your parent graph, and you can do the transformations to those 2 points. For stretches and compressions, the only one you have is y by 4. For shifts, translations, you are going to go left 1 and down 5. And because we are going to the left one, our asymptote will go to the left one as well. So now x equals -1, you'll have the point 0, -5. And 2, -1. And you have the general shape of the log graph again. I'll move it back up for the other one. Here now we have a natural log graph. So parent graph, asymptote at x equals 0, 1, 0, and e, 1. And what do we need to do on this one before we even start? Factor. Kaya, did you remember?
I did.
Awesome.
I got everything.
So you factor out the half. Now what, if you take a half out of 2, what number is going to go in there? 4. How did you figure that out? How do you figure out that it's going to be a 4? So you take 2 and divide it by half, because factoring is like dividing, and dividing by half is like multiplying by reciprocal, right? That's one way that you can do it. Often what I do in these situations is, before I write that number in, which is going to be +4, I ask myself, well, what number would have to be there so when I multiply it by half, I get 2? And the only number that you can multiply by half and get 2 is 4. So either you're dividing like you usually do, because factoring is like dividing, or you can think of it that way. So again, you would take your points, 1, 0, e comma 1, and our asymptote. We'd go through here. We have two stretches. Your y values are going to be multiplied by 2, and your x values, because of that half, get multiplied by 2. And we have two transformations. We're going to be going left 4, down 3. When here, I'll write this point underneath because it's going to take a little bit more space. When I'm going left 4 from 2e, I'll have 2e minus 4, and down 3 will get me to negative 1. Wow. Beautiful. And what's going to happen to our asymptote? Since we're going left 4, our asymptote will change to x equals minus 4. So 1, 2, 3, 4. I'll start with the asymptote. X equals minus 4. Then I'll label the point that's easy, negative 2, negative 3. Now to label 2e minus 4, you're going to estimate that e is 2.7-ish, 2.71828. So if I go 2.7 times 2, I'm going to get 5.4 minus 4, about 1.4, comma, minus 1, 1.4 minus 1. Label that as best as possible, and I'll label it on here still as 2e minus 4, comma, minus 1. And there's our final graph after the transformations.